So some QBATT chat. Basically in the Insight we have a line which runs from the MCM to the ECM at the front of the car, and it tells the ECM what the quantity of battery is remaining. So it's a state of charge signal in effect, but it's a simple analog 2 kilohertz PWM signal which varies between 10 and 90% duty, 10% being battery empty and 90% being battery full. So we've been trying to manipulate or sort of help the ECM to decide when to charge, etc., by fiddling around with sending state of charge signals to the MCM from the BCM, etc., and that still has a part to play. However, if you want to directly control what the ECM sees, because the ECM only sees this analog signal on the QBATT line, it doesn't have any digital information about state of charge or anything like that, it just receives this analog signal. So if you want to have control of that, what you could do is use something like this. Now this is a repurposed 12F683 pick, which some of you might now have spare. So you can see the board here. I'll try to hold it steady. So this is just a simple piece of strip board. You can see exactly how it's wired, and I've tested the code on this, and the code is running fine, and I'll explain that more in a moment. So we've got a couple of connectors there. We've got an LED to say I'm alive. We've got the variable pots here, and the pick itself, and this is the programming header here for the program. So on the back side, if I turn it over, you can see where I've cut tracks or whatever, so you should really be able to probably duplicate that very easily just from pausing this video, perhaps printing that out, and again the same on the other side. So if you pause the video and print it out, you can duplicate that. So the output from this device is on this pin here, this one with a little purple mark on it. So that's the pulse width modulation out from the pick, and that will tell the ECM a state of charge, give the ECM a state of charge signal. And we've got plus 5 volts in here and ground, and you can get these from ECM connectors, same ones which are used for the IMA boost, as sensor signals, sensor power supplies basically. So we've got plus 5 volts and ground, and then we've got the output here. This one is not used at present, you don't need that. So basically what you do is you locate your QBATT line near the ECM, you chop the line, and you put the piece of wire that's going into the ECM into here basically. So the signal from this device goes into the ECM, and then you connect obviously 5 volts and ground to the inputs here. So it's as simple as that basically. So when you rotate the part, I think it's that way, that's minimum, that's 10% duty down there, and that's full duty up there, so that's 90% duty there. So that's like maximum state of charge. If you probably have it up here, it probably won't allow regen, etc. And if you have it right down there, then it won't allow assist, it probably won't auto start, etc, etc. So that's it, it's very simple. I'll publish the code in a couple of minutes time once I've got the video sorted out, and it needs somebody to try it out now. I'm busy doing lots of other stuff, so I'm not going to be trying this, but if you want to try this as an independent method of controlling the state of charge, then you can. Obviously what I'm focusing on is trying to automate this process, which is what you saw in the earlier video, where I'm using the BCM interceptor to drive the QBATT line based on calculations of average voltages versus state of charge. So that's where this is just a simple independent separate thing for people who want to control what the ECM sees, to try and get a bit more control over what it's doing and when it's requesting charge and when it's not requesting charge. So you could mount this however you like in a little box, and there you go. So that's that, very simple. Hopefully somebody can test that and report back.